Hello everyone and welcome to the ANC Awards 2020, the first ever that we've held as a virtual event. There's been so many amazing projects entered for this year's awards, and it's been a very hard job for the judges to narrow them down to the final shortlist. I'd like to say a huge thank you to the judging panel for their hard work, time and dedication to decide on the final winners, all done virtually. The format for the awards will be as follows. Each finalist has been asked to produce a video to explain their shortlisted projects. We'll show an overview of each category and then the full video of the winning project. There will be a dedicated area on the ANC website which will host all of the shortlisted videos should you wish to watch them after the event. But bear in mind that it'll take a few days before we can get them available, but keep a lookout on social media channels for any updates. I'd like to say a massive thank you to our sponsors, to ANV Measurement Systems who are sponsoring the environmental category, to Acoustics One for sponsoring the building acoustics category, to Mason UK for sponsoring the innovation category, and lastly to CMS Danskin for sponsoring the vibration prediction and control category. Also, thank you to all of you entrants for taking the time to put your videos forward and produce a video for the event. We could not do this without you. Our team's done the best to maintain the production values in the videos, but note that the sound may differ slightly from video to video. I'd now like to hand over to our Master of Ceremonies, who will take you through the rest of the event. Thank you very much.
Thank you, Paul. My name is Craig Kay, and I'll be taking you through the ANC Awards 2020. The aim of these awards is to promote and recognise the excellence among the UK acoustic consultants by showing examples of work that displays innovation. To kick off, we have the first category, Environmental, which is currently sponsored by ANV Measurement Systems. And the nominees are Miller Goodall for 13 Dalton Square, we have an overview here on Miller Goodall's work. Holy! For ground run enclosure at Cambridge Airport. We have details presented here on Hawley's project. And Arup Acoustics for HS2 West Ruislip. Let's look at an overview of Arup's submission. Commended is Arup Acoustics for HS2 West Ruislip. Highly commended is Miller Goodall for 13 Dalton Square. And the winner is Paul Lee for ground run enclosure at Cambridge Airport. Congratulations to all the team.
Hello and good afternoon. My name is Daniela Philippe from Horley, and I'm going to talk to you about the development and commissioning of one of the world's largest four-sided acoustic enclosures. This enclosure was designed for the ground testing of engines of some of the largest and loudest commercial and military aircraft after they have undergone maintenance at Cambridge Airport. The ground run enclosure is 74 meters wide by 92 meters long. Its side and back walls consist of 20-meter high composite perforated metal panels with Class A sound-absorbent treatment on the aircraft side. The front wall is made of two doors, each comprising full-height, 2-meter thick acoustic louvers designed to allow the non-turbulent flow of up to 2 tons of air per second into the enclosure. Each door weighs approximately 200 tons and is electrically driven. A metal blast deflector is also present at the rear of the enclosure to smoothly direct propulsion air efflux upwards and prevent turbulent air recirculation back into the test volume. Once construction was completed, the next big step was the acoustic and aerodynamic commissioning of the enclosure. The design of the GRE was based on noise emissions of a Boeing 777-300ER jet and the Lockheed C-130J turboprop. This meant that upon completion, testing of the GRE with these two aircraft types was required. Obtaining a C-130J turboprop aircraft for the measurements was relatively easy. Sourcing a Boeing 777-300ER, on the other hand, was significantly more challenging. A shortage of jet aircraft at the time of the measurements meant we could not get our hands on one of these. Therefore, we hired a Boeing 767-200SF in its place, all the way from Turkey. With our noise sources sorted, we could start the acoustic commissioning process. The methodology for the measurements evolved quite significantly. It culminated in measurements at a total of 9 locations around and in the GRE, the use of 21 sound level meters, the development of in-house software to access all of the sound level meters simultaneously, optimized measurement stations to allow speedy deployment, and the use of approximately 1 kilometers of Ethernet cables. On top of this, we had a team of more than 50 people on site to help us. The first commissioning tests were carried out with the C-130J aircraft. The rigorous and meticulous planning proved its worth. With the aircraft engines run up to maximum power, the real-time analysis of the measurement data enabled immediate confirmation of compliance with the agreed limits. The testing of the alternative jet aircraft was not, however, as straightforward. First, as the target noise limits used in the design of the GRE were based on a Boeing 777, and as we couldn't get one for the measurements, we needed to determine new target noise limits based on the Boeing 767. This resulted in the need to carry out new free-field measurements to determine the source levels. Ideally, the revised compliance limits would have been determined before the GRE tests. However, operational issues dictated that the aircraft needed to be installed in the GRE upon arrival. Once the aircraft was in place, all of the monitoring systems were then deployed and the noise measurements completed without any data loss. Once the aircraft was taxied to the open runway, the monitoring stations were disassembled and redeployed, the free field measurements were completed, and the results converted into compliance limits. Comparison with the in-GRE measurements revealed the unthinkable. The GRE was apparently non-compliant. An explanation was demanded, and quickly. The day and night before the measurements, there was a lot of heavy rain. The ground had become completely waterlogged. And as the temperatures rose during the day of the measurements, they caused the water on the ground to evaporate. But how did this affect the results exactly? The aircraft was placed on the runway with an array of microphones at approximately 150 meters from its center. The microphones were located at both 1.5 and 4 meters above ground. With this setup, we expected sound waves to travel in a straight line from the aircraft to the two measurement heights. We also expected a difference of not more than 5 dB between the two microphones, given the relatively small height difference. The evaporative temperature gradient caused a strong negative sound speed gradient. This led to significant differences in sound pressure levels between the two measurement heights. So, In summary, a strong sound speed gradient resulting from very specific weather conditions was concluded to be the cause of the GRE non-compliance. As soon as the weather allowed, the free field measurements were repeated and the noise compliance limits recalculated for comparison with the in-GRE measurements. The GRE successfully passed all noise compliance tests, but not without a few sleepless nights for all of those involved.
Congratulations!
Thank you. It's great to be the 2020 recipient of this award. However, I could not let this opportunity go by without actually giving a shout out to the amazing team of acoustic engineers that supported me throughout the GRE commissioning process. Without them, this would not have been possible. We all gave up parts of our life to actually make that happen. So Adrian, Andrea, Andrew, Charlie, Celia, Julia, and Mark, we did it!
Moving to our next award, Vibration Prediction and Control, which has kindly been sponsored by CMS Danskin. And the nominees are WSP for their work at Hanover Square, Let's look now at the details of WSP's approach. And Adrian James Acoustics for vibration impact on bugs. Let's look closer at Adrian James Acoustics' work. Commended is Adrian James Acoustics for vibration impact on bugs. And the winner is WSP for their work at Hanover Square.
Welcome to our video about Hanover. This is a project that we were really proud to be part of, working with our client on this prestigious central London mixed-use development. At WSP, we've adopted an advanced approach to the prediction and assessment of vibration, drawing on the world-class knowledge in our team and using a creative approach to enable high-quality development. So, here's what we did.
Hanover is a complicated master plan scheme comprising a new central London mixed-use development by Great Portland Estates and the GHS Limited Partnership. 18 Hanover Square was built over a new underground railway station, sharing the same structure. A tunnel ventilation fan system was required for the railway, and a study by the rail company highlighted noise and vibration challenges for buildings adjacent to the fan room. In our case, the typology of the building meant that noise from the fans imparted into the structure had the potential to transmit up the concrete core and radiate into the office floors. A method of assessing the re-radiated noise was developed by the rail company, but it was based on two-dimensional finite element theory, considering nearby adjacent structures, and did not account for fan rooms below ground. We sought to develop our own bespoke methodology, utilising three-dimensional finite time difference modelling. These modelling techniques are commonly used for radiated noise from rail activities, but are not often used for assessing re-radiated noise from a continuous source. We identified that the sound transmission into the room primarily came from the floor and ceiling. The room boundary walls were not a major contributor of sound, and instead control the modal response of the sound when in the room. As expected, the room modal response effects differed depending on heavy or lightweight wall structures. The modelling results for the open plan and cellular scenarios indicated excesses above the adopted room criteria. The developer was already nearing completion of their REBA Stage 4 design above the station and could not accommodate any mitigation within their demise without significant project impact. It was agreed that the best option was to mitigate at source. The main contributing noise element in the fan room was a large single-sheet steel transition piece between the fan and the in-duct silencers. This led to developing a mitigation solution with the rail company and their consultants, comprising an enclosure around the transition pieces of the fan. Upon completion of the fan rooms, in situ sound pressure levels were measured to a methodology defined by WSP catered specifically to capture low frequency room sound pressure levels using the ISO 16283 corner measurement method. It was found that these measurements were 17 dB lower than the original source estimations provided to WSP. The numerical model was amended to include this data to increase its accuracy. The revised modelling outputs indicated that there would be no exceedance in the OSD. WSP undertook measurements within the completed OSD, which validated that re-radiated noise was in reasonable agreement with the revised numerical modelling predictions. Noise levels were found to be no more than NR17, verifying that the office space is uncompromised and leaving our client very satisfied.
WSP were instrumental in ensuring that any noise or vibration from the station benefiting Hanover Square would not be a concern. This was carried out at a comparatively late design stage of the project. The initial study and calculation was further demonstrated by on-site testing by WSP once the fans were commissioned and operational. The modelling work carried out by WSP alleviated the need for any further structural isolation, which would have had potentially serious implications in terms of programme or cost.
By developing a bespoke methodology and working collaboratively, we avoided potentially significant mitigation, which would otherwise have been required to be implemented by the rail company or our client. This bespoke assessment methodology can be used in future to advance our industry's capabilities and understandings. We are WSP.
Congratulations!
I'm sorry I can't be with you in person tonight. This dreaded coronavirus has got the better of us this year. Anyway, I'm very humbled and honoured to accept this award with George de Avilés on behalf of WSP. It was clear from the start that we had significant challenges to overcome, and to resolve these required our client, Great Portland Estates and the GHS Partnership Limited, to believe in our capabilities. So I thank them for enabling us to win this award. George would like to say thank you too. Obrigado.
Our penultimate award is the Innovation Accolade, which has kindly been sponsored by Mason UK. And the nominees are WSP for their work at Hanover Square, Atkins & Jacobs for roadside vehicle noise measurement, and Apex Acoustics for acoustic performance evaluation through listening. The judges have recognised all entrants as deserving an Innovation Award. So well done all! We've already heard from the WSP team, so here's more on Atkins & Jacobs and Apex Acoustics projects. More details on Apex Acoustics entry.
According to the World Health Organization, noise pollution is one of the top environmental risks affecting physical and mental health and well-being. High levels of noise have been linked to a number of human health issues, including cardiovascular disease, sleep disturbance, and cognitive impairment in children. Vehicle noise is a significant cause of noise pollution, particularly in urban environments. Excessively noisy vehicles, which have often been modified, also lead to significant annoyance and complaints from the public throughout the UK. However, many vehicles are found to be in contravention of the relevant noise regulations when stopped in use on the road. The Atkins-Jacobs joint venture researched this issue to identify potential improvements to policing methods for noisy vehicles and highlight any technologies that could be used to aid detection and enforcement. The primary aim of the project was to understand if there are any reliable and robust ways of ascertaining noise emissions from an individual vehicle at the roadside, which could then be used for enforcement purposes. The work started with a desktop study that involved reviewing different methods for measuring vehicle noise, reviewing enforcement approaches used in the UK and abroad, surveying police forces and local authorities to find out more about how they approach this issue, and identifying potential technologies that could achieve the project outcomes. From this work, we found that no off-the-shelf products exist that can be used for enforcement, but a noise camera could be developed for this purpose. We designed and trialled a noise camera in the next stage of the project. But what is a noise camera? A noise camera is an automated system that can detect and identify vehicles and their noise emissions. The key elements of our noise camera comprised a video camera pointing at each carriageway, a speed radar, an automatic number plate recognition camera to obtain the vehicle's number plate for enforcement action, and an acoustic sensor such as a microphone to measure sound from vehicles as they pass by. As a vehicle passes the noise camera, information is collected about the vehicle, including its noise levels. If the vehicle is excessively noisy, the noise camera triggers an alert and an evidence package is created for enforcement.
The project is special because it takes well-established technologies and adapts them to create something new that could solve a real-world problem and reduce noise pollution. In doing so, it's created a space for others to build upon these ideas.
Assembling the noise camera was a key technical challenge that I was able to achieve by collaborating closely with other engineers.
The project is special as it is a positive acoustic story, having successfully identified a potential solution capable of reducing a source of noise pollution. It has sparked interest in the issue from the acoustics industry, local authorities and people affected by excessively noisy vehicles in the UK and Europe. The media attention from the project is inspiring others to tackle the issue.
Getting an automated system to work was a real challenge, and getting it to work successfully has been a real highlight for me.
Our team overcame several complex technical challenges, including designing, building and deploying the noise camera within a 6-week period, identification of suitable trial sites, and ensuring that the evidence package from a noise camera could withstand legal scrutiny.
We worked closely as a team to ensure that the outputs of our automated processing were as accurate as possible.
So why should we win? Well, it's a good question. I think we show really good teamwork, drawing together lots of specialists from different areas, working together cohesively on a team and delivering something that really works. It's been really good fun.
The project has proved that it is possible to take existing technologies and apply them in a way to achieve something new.
Congratulations!
Winning the ANC Award for Innovation would mean a lot to the project team, and not just those who work in acoustics. As the project manager leading this innovative work, it would be a huge honour for my team's achievements to be recognised by the ANC in this way, and for the acoustics industry to acknowledge my client's commitment to reducing noise pollution.
I'm really pleased to have won this award. It means a lot, the great combination of fun, technology and teamwork working together. It's been really good fun. Thank you.
I was already immensely proud to have worked on this project, but having our efforts and innovation recognised by the acoustics industry makes me feel truly honoured to have been part of it.
Welcome to The Word in South Shields. We're going to take you on an audio tour through this building.
And let's move across to the area where the books are. This is where we notice the biggest change in acoustic environment as we walk from the open plan into the books. Here we go. Leaving the sound of the atrium behind, the whole response of this space changes entirely.
We want our building to sound like that, is what many architects and clients told us when they heard that little piece of film. So we just made that casually on a mobile phone. Actually, it was for another ANC Award entry a few years ago. But with a response so powerful to a proposal for acoustic design, we realised we should be using this type of material more often. There's a change of emphasis in the world of real estate, from evaluation against benchmark design criteria and towards an evaluation of how well the buildings actually perform in use for the occupants. Look at standards like WELL or FitWell that look at the conditions for the occupants, or the Better Buildings Partnership that looks at the energy performance in use. And this has never been more important than at a time like now, where we've all evacuated all our offices and we're thinking about how we're going to use them again in future. They'll need to meet our acoustic needs in practice. Here's a little example of a film video that we made more recently. So this is a building that meets the benchmark design criteria, but the occupants were unhappy with it, far too noisy. Have a listen. There's a popular refrain that architects don't design with their ears, but if they did, what would it sound like and what would the process be? Have a listen to this building that by all accounts is very popular with the occupants.
This is a quick walk through the floor space. As you enter the reading room, you see the collaborative areas with high tables and booths. Then there is the open plan areas.
So our new method is all about creating a system for benchmarking the acoustic performance in use. Before we start filming, we have to survey the building, get an appreciation of the different soundscapes and how they vary across the building and at different times. Think about how we can capture those, then reproduce and even juxtapose different images to maximum effect. So we're using point of view video and point of hearing audition, so that what you hear is exactly what somebody who was standing at that place, sitting at that place, would have heard in the building. There are many more challenges in this method and using this type of media, but it's such a great communication tool because it overcomes all the jargon. We don't need to talk about reverberation times or ambient noise or anything else. People can hear what it sounds like and decide if they want their building to sound like that or not.
Congratulations!
We're fantastically excited to be nominated in this way. When we always love this event. It's great to see all the ideas that people put forward, and we really appreciate everybody sharing them like they do. We hope other people will use our method that we've proposed here tonight as well. It's there for everybody to use. We hope that people will use it to help communicate, demystify acoustics, improve the acoustic design of buildings, help create more sustainable buildings in practice. And we might have to buy a bigger cabinet for all our awards too. Thank you very much.
Congratulations! We conclude with our Building Acoustics category, kindly sponsored by Acoustic One. The nominees are Cole Jarman for the Courtyard Project, looking now at Cole Jarman's overview. Hayes Mackenzie for 25 Clifton Road. More information on Hayes Mackenzie's work. Paul Lee and RBA Acoustics for Lafayette 4 Pancras Square. More on the work of Hall Lee and RBA Acoustics. And ACOM for the English National Ballet. Here's an overview of ACOM's project. Within this category, the judges have made an additional award to recognise the excellent example of the contribution acousticians make to projects which don't attract as much attention as the more prestigious buildings. The smaller consultancy award goes to Hayes Mackenzie for 25 Clifton Road.
Hayes Mackenzie and UK ProBuild have both worked on the project which we've entered, and we're very appreciative to have been shortlisted for the award. The project is a basement flat conversion on an end of terrace property in Salisbury. The unique structural issues with the property led to some interesting problems with sound insulation. The reason we were able to overcome the problems so effectively was mainly due to a good relationship with UK ProBuild, without using too much in the way of specialist products or significantly adding to the cost of the build. The steelwork in the property was the main issue to overcome, and through collaborative design we ended up with an interesting design of steelwork that had lots of different sections all isolated from one another rather than large pieces of steel that would transmit sound easily. There was also some innovation on the main king post, which was a box section. We filled that box section with acoustic expanding foam, which made a huge difference to its resonant properties and deadened the sound transmission significantly. The results were incredible, much better than the building regulations requirements, and closer to what you might find in recording studios than what you'd expect in a residential flat.
Congratulations!
Hi, I'm very honoured for our project to even have been considered alongside some of the large projects that are included on the shortlist. I mean, the difference in scale between our flat conversion and the English National Ballet is not even worth trying to put into words. For us to win this award is, I'm speechless. I can't believe that we've been voted to win the award, so thank you. That's all I can say.
For the remaining entries, the results are: commended is Cole Jarman for the Courtyard project. Highly commended is ACOM for the English National Ballet. And the winner is Hall Lee and RBA Acoustics for Lafayette 4 Pancras Square.
Hi, I'm Matt Brown from Hawley Acoustics.
I'm Andrew Heath from RBA Acoustics. We're here today to talk to you about Lafayette, the socially distanced 2020 ANC Award.
And this is a collaborative entry, and it's a bit of a success story of how two acousticians can work together rather than against each other to incorporate a fully fledged music venue into a mixed-use building. The project was born when the building owner, Argent, came to Hawley and asked whether it was mad to even be considering the incorporation of a live music venue within a mixed-use building, knowing full well that Universal, the office tenant, have a recording studio located on the first floor. So, we hired an events-grade sound system and made some noise, to gain a detailed understanding of how the building would respond to high levels of live music. If the plans didn't seem mad before, they certainly did now. The outside of the building shook, and the thud of the kick drum could be felt as high as the 9th floor. This obviously didn't help to allay Argent's fears. With the challenge laid out, we took the measured results and used these to consult with Argent on noise intrusion criteria to be achieved, both within the new first floor restaurant that was to be developed directly above the venue and also throughout Universal's demise. With these agreed, we developed a series of design measures, including a combination of floating floors, mass barrier ceilings, and linings to the common structural walls and columns, and presented these to Argent to demonstrate that their ambitious plans could be realised. With Argent reassured, the necessary works were divided into a landlord specification and tenant's work package, whereby acoustic specialists from both teams would be required to work closely together to ensure that the demanding noise control measures would be successfully implemented into the building. RBA Acoustics were brought in by Lafayette to act as the tenant's consultant.
So Lafayette brought us on board to develop Hawley's noise control measures through technical design and completion, as well as to assist with licensing agreements for the main venue and for the other bars and halls within the complex. There was an aspiration for Lafayette to operate at effectively unrestricted noise levels, meaning we had to undertake further detailed analysis of the level of insulation required, the noise level distribution and the control of flanking paths. It was essential to work closely and directly with Hawley throughout the process to ensure that both acousticians were happy and that the landlord and tenant aspirations were achieved on all counts. Now I'm going to take you through a couple of the specific design challenges. While the space initially felt quite cavernous, it quickly became apparent that there was a conflict between the available head height, which you can see we're quite close here, and the depth of the mass barrier ceiling. So we had to find a way to overcome this issue. So the way we did this was to use Odeon room acoustic modelling to look at the low frequency energy distribution around the venue, and it actually showed there was a reduction in low frequency energy in this area, which facilitated a reduction in the mass barrier ceiling depth. We've got these two huge columns running throughout the entire building, and obviously run through from the venue to Universal's demise. We had to look at ways to skinny these down because they were affecting sight lines, so we looked at reducing the overall lining thickness while increasing the mass of the lining. As the mezzanine is an isolated steelwork structure, we had to ensure the natural frequency of crowd movements didn't work against the natural frequency of the acoustic isolation bearings. So here we are in the finished venue. After many months of site inspection visits, mainly stopping the mechanical engineer and structural engineer from knocking holes in the acoustic wall linings, we came to do the final commissioning. We hired a PA rig and demonstrated that the sound transfer throughout the development to other areas was suitable and passed on all counts.
And what this shows is how successful the collaboration between two acousticians on these highly challenging, technically complex jobs can be. Ultimately, what we've done is we've delivered the necessary acoustic quality to enable the venue, Lafayette, to operate at effectively unrestricted noise levels, whilst simultaneously allowing Argent to sleep at night knowing that they're not going to be annoying their other tenants. So just to finish off, just to say thank you for listening. I've been Matt Brown.
And I've been Andrew Heath, and we hope you've enjoyed listening to this presentation as much as we enjoyed working on the project.
Thank you.
Congratulations!
Hi, I'm Matt Brown of Hawley Acoustics.
I'm Andrew Heath of RBA Acoustics. Thanks very much. It's great to be recognised for winning the award. After many months of hard work with Matt reviewing and helping the process along, we finally delivered a really incredible project, and we're really pleased to be part of it.
Yeah, just to echo what Andy said, it's been a great collaborative effort. When we first set off, many years ago doing the testing, we didn't really know what it would take to actually even get the venue into the building. So it's great to be able to deliver at the end, and hopefully people will be able to go down and enjoy some live music at a great venue on the other side of lockdown. Thank you.
Great stuff. Thanks very much.
We thank you for watching. We hope you've enjoyed the ANC Awards 2020. Full videos for each finalist entry will be shown on the ANC website, and the whole ceremony is going to be made available for later viewing too. Thank you for watching, and again to the sponsors for bringing the awards together.